Welcome to Section 8, Lesson 3. The previous two lessons covered factoring out a GCF and factoring by grouping. Today we tackle the most common trinomial pattern in all of algebra x squared plus bx plus c, where the leading coefficient is 1. The technique is fast once the sign rules are clear. The factored form is two binomials in the shape x plus p times x plus q. The job is to find p and q. Multiplying out and matching coefficients gives the two equations that drive everything. The product of p and q must equal c, and the sum of p and q must equal b. List the integer factor pairs of c, then test which pair sums to b. With small values of c, there are only a handful of pairs, so the search finishes in seconds. Sign reasoning narrows it further. When c is positive and b is positive, both numbers are positive. When c is positive and b is negative, both are negative. When c is negative, the two numbers have opposite signs. Three quick examples in this lesson cover the three sign cases. Watching them in order builds the muscle memory you need so the trinomial pattern becomes recognizable on sight. Take x squared plus 7x plus 12. Both b and c are positive, so both numbers we are searching for must be positive. The search space is the positive integer factor pairs of 12. We need two numbers that multiply to 12 and add to 7. Two equations, two unknowns, but the integer factor structure makes the search fast. List the positive factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. 3 pairs to check, that is the entire candidate set. Check the sums. 1 plus 12 is 13, not 7. 2 plus 6 is 8, not 7. 3 plus 4 is 7, which is exactly b. The pair we want is 3 and 4. Write the factored form. The trinomial equals x plus 3 times x plus 4. The sign of each number lands directly inside its binomial, and the multiplication produces the original trinomial when expanded. Factor x squared minus 9x plus 20. Here b is negative and c is positive. The constant being positive forces both numbers to share a sign, and the negative b forces that shared sign to be negative. Reason through the signs first. C equals positive 20 means the product is positive, so the two numbers must agree in sign. B equals negative 9 means the sum is negative, so both must be negative. We are searching for a pair of negative integers whose product is 20 and whose sum is negative 9. List the negative factor pairs of 20, negative 1 and negative 20, negative 2 and negative 10, negative 4 and negative 5, 3 pairs matching the absolute value pairs of the positive case. Test the sums. Negative 1 plus negative 20 is negative 21. Negative 2 plus negative 10 is negative 12. Negative 4 plus negative 5 is negative 9, exactly b. Write the factored form. The trinomial equals x minus 4 times x minus 5. Both binomials carry minus signs because both numbers were negative. Verify by expanding the product term by term, and the answer collapses back to the original trinomial. Example 2. Factor x squared plus 2x minus 15. The constant is negative this time. That single fact tells you the two numbers have opposite signs, and the bigger one in absolute value matches the sign of b. Reasoning. C equals negative 15 means the product is negative, so the two numbers cannot share a sign. B equals positive 2, a small positive number, means the larger absolute value should be positive and the smaller one negative. List the factor pairs of 15 with mixed signs. The absolute value pairs are 1 and 15, 3 and 5. Each absolute pair gives two sign pairs depending on which side gets the plus. Test sums. 5 and negative 3 sum to 2, exactly b. 3 and negative 5 sum to negative 2. The wrong sign but the same absolute value. So the answer is 5 and negative 3. Write the factored form. The trinomial equals x plus 5 times x minus 3. One binomial has a plus, the other a minus, and that asymmetry is the visible signature of a negative constant in the original trinomial. 3 takeaways for trinomials with leading coefficient 1. They turn factoring into a small search problem you can finish in seconds. Two equations drive everything. The product of the two numbers equals c, the constant of the trinomial. The sum of the two numbers equals b, the coefficient of the linear term. Find a pair satisfying both, and the trinomial is factored. The signs decide where to look. When c is positive, both numbers share a sign, and that sign matches the sign of b. When c is negative, the two numbers have opposite signs, and the larger one in absolute value sides with the sign of b. The mechanical procedure is to list the integer factor pairs of c, applying the sign rules, then check which pair sums to b. With small c, the list is short and the search finishes immediately. Once you find the pair, write the two binomials and you are done.